Hi, this is Mrs. Bowen with the University of West Florida. Welcome to College Algebra. This is lecture 6.5, Logarithmic Properties. And so that's what we're going to be doing today. Before we get started though, I want to remind each of you to please be diligent to do all of your homework. Again, exam 4 can be some of our most challenging material to cover. So it takes extra study to make sure you're prepared. What you're going to see today is absolutely fun. I know you're rolling your eyes and laughing and saying, really, how can it be fun? It is. It's fun math. I enjoy today's lecture and the math that we're doing today. And when I do it, because of my enthusiasm, sometimes it might look really simple. And that simplicity can be deceiving. So it's very important that you practice for yourself these properties that we're going to be learning today, and that you practice them over and over, especially before you take exam 4, to make sure everything's fresh in your mind and that you remember all of the properties. Alrighty, so let's get started. Okay, so here we go. Properties of logarithms. Property number 1, log base b of mn is equal to log base b of m plus log base b of n. What does this actually mean? This means that if I have two factors, and I'm taking the log base b of two factors, that I can break them apart where I take log base b of factor 1 and add it to log base b of factor 2. So that would be something like this. If I had log base 6, whatever that, whatever b is, we'll let it be equal to 6, of x plus 2 times x minus 3. Those are two factors, right? So I could write that as log base 6 of x plus 2 plus log base 6 of x minus 3. And I ran out of room. Hopefully that'll be on the video. Part 2 here, property 2. This is log base b of m divided by n. Again, two factors. One factor divided by another factor is equal to log base b of factor m subtract log base b of factor n. So if I had log base 6 in my two factors would be x plus 2 divided by x minus 3, then I could rewrite this as log base 6 of x plus 2 subtract log base 6 of x minus 3. It's numerator, subtract the denominator. Okay? Looking at our next one here, property 3. This says if I have log base b of m raised to the kth power, that I can take this k that's up here and bring it down out front. See, it's out front right here. Okay, so I just can bring it down out front. And that would be something like if I have log base 6 of x plus 2, let's say to the 1/2 power. I can bring that 1/2 out front and then multiply it by log base 6 of x plus 2. So that's how those properties right here work. Now we're going to be practicing those properties more in depth. First one right here. Number 1, our instructions say rewrite each expression as the sum or differences of logarithms and then simplify. You've got to make sure that you remember to simplify. Okay, since we have these three right here and they mirror image what I taught up here, if you're up to it, push pause, solve all three, and then you can see if you get them right by pushing play afterwards. If you're not quite ready for that challenge, don't worry about it, just let the video play. Okay, here we go for problem 1. As you can see, we have two factors. The first factor is 9 and the second factor is y. So in essence, we're saying m is equal to 9, n is equal to y. So to rewrite this, we would say that it's log base 2 of 9 plus log base 2 of y. And so we wrote this as a sum. The next one right here, we would be able to say that our m is equal to 2 and our n is equal to x. So to write this as a difference, it's going to be log base 7 of 2 minus log base 7 of x. Number 3, this one here, we're simply going to take our power, it's called the power rule, and apply it where we bring it down out front. So we're going to let our negative 2 come out front, and we're going to say multiplied by log base 2 of x. If you did all 3 of those and you got them all 3 right, I want you to text me or email your instructor the code word marshmallow. The code word is marshmallow if you got all 3 correct. If you gave it the good old college try, but you got something wrong, not a problem, but I do want to know that you made the effort, and so does your instructor. So please email us or text us the code word RICE, and then we'll know that you didn't quite get it right, but you did give it the good old college try, and we appreciate that. Let's look at problem 4. This one here, we're going to be combining different techniques. You're going to notice that we have several factors in the numerator, several factors in the denominator, and then we have a division here. The first thing you really want to do is take care of this division. So we're going to go log, and we don't have a base, so it's base 10, so we don't have to write anything down, of RS squared T. That's the numerator right here. Subtract our denominator. It's going to be log U cubed V5. That was step number 1. Step number 2 is we're going to break apart these factors in here, okay, through addition. So this is going to be equal to addition, 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 okay? So it's log base 10 of R plus log base 10 of S squared plus log base 10 of T. Subtract. Put all of this in parentheses now because we're going to expand this out. So always put this in because otherwise you're going to forget to distribute the negative, and therefore you're not going to get the problem 100% correct. And that makes instructors sad. So here we go. This is going to be log base 10 of U cubed plus, because this is multiplied, it is a plus at this point, log base 10 of V5. Close your bracket right there. Okay, close that off. Now, we're going to work on the left-hand side. There's nothing to do with this. It is as simplified as it can be. So this is going to be equal to log base 10 of R. This one here, though, we have an S squared. So we're going to apply the power rule. Plus 2 log S. This one here is as simplified as it can get. Plus log T. Now, this one here, I'm going to do 2 things in one move. I'm going to apply the power rule here and here, but I'm also going to distribute my -1 to both terms, my negative sign to both terms. So that negative is going to come right here, and we have a negative times log U to the 3rd power, but that power to the 3 is going to come out front, and it's going to become log 3 log U. Now this negative times this positive gives me a negative. Okay, you've got to make sure you distribute that. And then we have V to the 5th, so that's going to be 5 log V. I don't have anything in common here that I can combine, so this right here is my final answer right there. Alrighty, let's look at number 5 here. Number 5, I have log base M, 4th root, x to the 5th, y to the 7th, divided by z to the 9th. So let's rewrite that as this. Log base M, I'm going to put parentheses, I'm going to go x to the 5th, y to the 7th, divided by z to the 9th, all raised to the 1/4 power. The 4th root can be rewritten as the 1/4 power. Just like if it was the square root, I could raise it to the 1/2. If we're taking the fourth root, we're raising it to the 1/4. So to get rid of this, the first thing I'm going to do is the power rule. We're going to bring it down out front. So this is going to equal 1/4 times log base m x to the 5th y to the 7th divided by z to the 9th. Now I'm going to go ahead and break up the numerator and the denominator. So this is going to be equal to 1/4 times log of x to the 5th, y to the 7th. X to the 5th, y to the 7th. Subtract log base m, this needs a base m on it also, z to the 9th. Bracket. Now we're going to break up this into multiplication, and we're going to then, after that, do the power rule. But let's first just get this broken up. So this is going to be equal to 1/4 parentheses log base m x to the 5th plus log base m y to the 7th. So all I did was break those two things up. Now I'm going to go subtract. I don't have two factors there. I just have z raised to the 9th power. So I'm going to apply the power rule, which says I'm going to take the 9 and bring it out front. So this is going to become 9 log mz. Okay, now I have one more thing to do. Actually, I have about 2 more steps to do. The next one is going to be distribute the 5 down out front on both of those. So this is going to be equal to 1/4 bracket 5 log base m of x. Take this 5, bring it down out front. Plus, take my 7, bring it down out front. 7 log base m of y minus 9 log base m of z. Just copying that on over. I have one last step. You see this 1/4 right here? I need to distribute it to each and every term. I'm only going to distribute it though to the numbers out front of the logs. So my final answer here is going to be equal to 1/4 times 5, 5/4 log base m of x. 1/4 times 7, so plus 7/4 log base m of y. 1/4 times a negative 9 minus 9/4 log base m of z. And that is my final answer right here. Alrighty, it's a lot of fun. The one last thing you'd want to make sure is that you can't simplify any of the fractions, and we can't, so we are done. Let's look at number 6. Number 6 is also going to be a lot of fun. The first step here is just going to be to rewrite this. We have the log, we have brackets, and we have factors. This is a factor, this is a factor. Recognize that we have an m and an n multiplied by each other. But I want to rewrite it where I have everything raised to an exponent. So I want to get rid of my cubed root here and write it to the power of 1/3. So this is going to be log base 10 of 2x squared minus 5 raised to the 1/3 power times x minus 4 raised to the 5th power. Again, remember, this is a factor like m. This is a factor like n. So in essence, I have two factors multiplied by each other, which means I can separate them into addition. So this is going to equal log base 10 of 2x squared minus 5, 2x squared minus 5 raised to the 1/3 power plus log base 10 of x minus 4 raised to the 5th power. Okay. The next thing I'm going to do is bring my powers down out front, applying the power rule. So this is going to be equal to 1/3 log 2x squared minus 5 plus power rule, bringing that 5 down, 5 log parentheses x minus 4. And that is our answer. We cannot simplify it further than that right there. All righty, I hope you're doing well. This one here says, write each expression as a single logarithm. So basically what we're going to be doing is working backwards. We're going to be putting things back together. I always like to say we're going to smash things back together. We broke everything apart, now we're going to put it back together. So I want you to notice right here that we have a power that was pulled out front, so that's going to go back there, and that's going to go back up, okay? And then I have, with addition, 2 factors, an m and an n. So we're going to put those back together. So this is going to be equal to, the 2 is going to come back up, so it's going to become log of x squared plus log of y cubed. Now we have 2 factors, and we can put them together through multiplication. So it's log x squared y cubed, and we're done. This right here is the answer. After watching that one, why don't you pause the video and try number 8 on your own, recognizing that we have a subtraction, so that's going to be division. Push play when you're done solving it to see if you got the right answer. Welcome back. The first thing I want to do on this one is I'm going to apply the power rule in reverse, and I'm going to raise each of our factors to the appropriate exponent. So this is going to equal log a to the 1/2 subtract log b to the 9th power. I have a subtraction sign, so that means this is going to be my numerator, this is going to be my denominator. So this is going to be equal to log a to the 1/2 divided by b to the 9th. And this right here is our answer. How'd you do? Hopefully you got it right. If you did, I'd like you to give me the code word mango, M-A-G-O, M-A-N-G-O. And if you did not get it right, but you tried, send me the code word turnip. Okay, code word is turnip if you did not get it right. Number 9 here. We're going to be doing lots of different things. I want you to notice that we have several different powers that we're going to be raising up, okay? Notice they're all the same base. We do have to make sure that they're always the same base. We have some multiplication that's going to go on, and then some division. So let's go ahead and get busy. So we're going to first bring up our power. So this is going to become log base 3 of x to the 7th plus log base 3 of y to the 5th minus log base 3 of z to the 8th. Okay, step 2, I'm going to go ahead and put these together through multiplication. So this is going to be equal to log base 3 x to the 7th times y to the 5th minus log base 3 of z to the 8th. Now I'm going to combine these through division. So now I have log base 3 x to the 7 y to the 5th divided by z to the 8th. And this is our answer right here. How'd you do? Hopefully you got that one right. Again, we're smashing together, we're combining, we're simplifying to the smallest expression. This one right here, we're going to notice that we have an exponent right there that we can raise up to. And so this is going to be rewritten as log of 2y plus 5 minus log y plus 3 to the 1/2 power. Now this is a factor and this is a factor. Same base. So now we're going to connect these through division. So this is going to be equal to log of 2y plus 5 divided by y plus 3 to the 1/2 power. And all of that is with the log right there. If you wanted to, we could rewrite this right here to the 1/2 power as in the square root. However you want to leave it is fine. If you want it to say that you want it to write it as log of 2y plus 5 divided by the square root of y plus 3, those are equal expressions and both should get you full credit on your exam. The next one here is called change of base. Well, we've already talked about change of base, haven't we? I showed that in the other videos, so you're kind of ahead of schedule on this, which is a great thing. So we have the change of base, and the change of base rule simply says that if I have log base a of x, that's going to be equal to the log of the tall over the log of the small, okay? So that's the rule right here, officially being introduced. So it says, let's figure out what this is. And it says, get out your calculator and evaluate it. So remember, you can't do a log base 7 in your calculator. You have to put it either to base E or base 10. I'm typically going to go base 10. So it's log base 10 of 215 divided by log base 10 of 7. Get out your calculator, go find it if you don't have it, punch it in, and I want to know if you ended up getting 2.76. I hope that you did, okay? If you did, send us the code word onion. If you didn't, send us the code word bat, okay? Hopefully you got that. If you haven't gone and gotten your calculator yet, go get it. Seriously, you're going to need it for the next couple problems, and it will be helpful to you. Problem number 12, practicing the change of base. Again, the change of base in this case is going to be log of 0.11 divided by the log of 4. Throw this in your calculator, and what do you get? I hope you got negative 1.59. Okay, so that is the end of today's lecture. I hope you enjoyed today's lecture. If you want more practice problems, reach out to your instructor. I'm sure that he or she will be happy to help you get some extra practice in. If you made it to the end of the video, how about you send the code word Ice Age. So send us the code word Ice Age and we will know that you made it to the end of the lecture, which today was very short. Take care and have a good day.